In this video, we will be looking at simplifying algebraic fractions, specifically looking at multiplication and division. If we look at a normal numerical fraction, we can actually simplify this fraction by doing something that looks like this. We can say that 6 is the same as 2 multiplied by 3, and 9 can be written as 3 multiplied by 3. So in effect, we've actually broken these numbers down into their factors. So from this we can identify that the 3's in this case are actually common to both and can therefore be cancelled. So when we simplify this, we actually end up with 2 over 3 as a simplification of this fraction over here. So when we look at algebraic fractions, which is over here, we can identify that this over here can be broken down into a factorized form, and we can do something like this. 2x plus 4 can be rewritten as 2x plus 2 all over 2. So 2 bracket x plus 2 is in fact 2x plus 4 factorized. So now we can look for something that is common to both, and we can see that the 2 there and the 2 there are common, and therefore those can actually be cancelled out. So we end up with x plus 2 as our answer. Alright, before I move on, this way is actually very, very wrong. Okay, so if we have 2x plus 4 over 2, a lot of people will do this. They will simplify this and they'll say 2 goes into 2 once and 2 goes into 4 twice. Therefore my answer must be 2x plus 2. That is wrong, wrong, wrong. Do not do it that way. Alright, so what are some of the rules? Well, when we multiply, we need to make sure that we factorize the expressions if possible. We then can cancel if and where possible, and therefore we can multiply the numerators and then we multiply the denominators. When we divide, we need to multiply by the reciprocal of the fraction, follow in the division sign, and then follow the rules for multiplication, which are those 3 steps up there. So let's look at some practical examples. In the first case, we are going to simplify by cancelling. So looking at this algebraic fraction over here, what do we see that is in common? Well, I can identify that x minus 4 and x minus 4 are common, therefore I will cancel those two out. And I can also see that 3 and 6 are multiples. Okay, so 3 goes into 3 once and 3 goes into 6 twice. So my answer therefore is going to be 1x plus 2 all over 2, and I know that this 1 over here I can actually get rid of, and my answer therefore is going to be x plus 2 all over 2. Okay, well here are 2 examples for you to have a crack at. Put the video on pause and come back when you're ready to see if you got it right. Alright, well how did we go with this one? Well, first thing I'm going to do is I'm going to factorize both the numerator and the denominator. So I'm going to say that it's going to be 5 is the common factor. 5 times what gives me 20, and it's going to be 5 times 4 and minus x. That's going to be my numerator, and my denominator is going to be 2, and it's going to be 4 minus x down the bottom. Now I can identify that that and that term over there are actually common to both numerator and denominator, so I can actually cancel those guys out, and my answer therefore is going to be 5 over 2. And we can simplify that if we wanted to 2 and 1/2. How'd we go with question 3? Well, I know this over here is in fact a perfect square. I can rewrite them as x plus 2 in the one bracket, x minus 2 in the other bracket, all over x plus 2. Now, do we see something that is common? Yes, we do. X plus 2 and x plus 2 are common, therefore I can cancel those two out, and my answer therefore is going to be x minus 2. Alright, well let's have a crack at multiplying algebraic fractions. So we have one fraction over here and another fraction over here, and we're going to multiply the two together. Now we know that multiplication we can actually simplify across the multiplication sign. So is there something on this side and this side that we can actually simplify? Well, I've identified that x plus 2 and x plus 2 can be cancelled because they are across the multiplication sign, and also x minus 1 and x minus 1 can be cancelled. I can also identify that 3 and 9 can be simplified. So let's go ahead and do all of that. So x minus 1 cancels with x minus 1, x plus 2 cancels with x plus 2, and 3 goes into 3 once and 3 goes into 9 3 times. So after all the cancelling, I can rewrite this as 1 times 4 all over 3x minus 7. And I know that 1 times 4 is 4 all over 3x minus 7. And that would be my answer. Right, well, let's have a go at dividing algebraic fractions. Remember, we've got a division over here, so we've got to do the reciprocal of the second fraction. Turn this into a multiplication sign. Right, put the video on pause and come back when you're ready. So I can rewrite this as x minus 3 x plus 4 all over x plus 7 multiplied by x plus 7 all over 3x plus 4. So I hope you can see that the second fraction over here has now been reciprocated, or the reciprocal of this, because of the division sign, multiplied. Our numerator becomes our denominator, and our denominator becomes our numerator. So now we can do some end fraction simplification, that x plus 7 and x plus 7 can be simplified, as can the x plus 4 and the x plus 4 over there. So we will end up with something looking like this. What is left over up the top? I have got x minus 3 all over x multiplied by 3. Therefore my answer is going to be x minus 3 all over 3x. And that would be correct. Okay, well, I hope you got those right, and that's pretty much all there is to simplifying algebraic fractions when there's multiplication and division involved.